Good morning, my dear students. Today we will study the last lesson of Unit 2, Algebra, Operations on Algebraic Fractions. Follow. Today we will study the other two operations, multiplying and dividing algebraic fractions. In each of the following, find n of x. This is in your booklet, page 50. Find n of x in the simplest form, showing the domain of n. We know the steps now. First, factorize. Second, find the domain. Third, simplifying. And doing adding, subtracting, multiplying, dividing. There is no problem with this. Example 1. N of x equals 3x minus 15 over x plus 3 time multiply 4x plus 12 over 5x minus 25. So my first step to factorize. I will take 3 here as a common factor, highest common factor, 3 out, open bracket x minus 5 over x plus 3 time 4 out, x plus 3 over 5 times x minus 5. Then find the domain. Look to the denominators. Here x should be negative 3 and here 5. So the domain equal r minus negative 3 and 5. Then I will cancel. We can't cancel in multiplication only. In the multiplication, we can cancel up and down in the same fraction or up and down with different fractions. So we can cancel x plus 3 up with x plus 3 in the second fraction down, x minus 5 up, and x minus 5 in the second fraction in the denominator. So this will be cancelled, and the remaining parts will be 3 times 4 over 1 times 5, so equal 12 over 5. It's easy to multiply. Example 2, x plus 2 over x power 2 minus 4 times 2x minus 4 over x minus 3. First step is to factorize. So x plus 2 over x minus 2 times x plus 2 times 2 out, x minus 2 over x minus 3. My second step, yes, exactly. Find the domain by looking down to the denominators. Here x2, x negative 2, x equals 3. So the domain equal r minus 2, negative 2, and 3. Then I will cancel the common factors up and down. In multiplication, we can cancel numerator with its denominator or the denominator with of the second fraction. So I will cancel x plus 2 with x plus 2 up and down, x minus 2 with x minus 2, and the remaining parts will be 1 times 2, 2 over x minus 3. This is a multiplication. Number 3, in page 51, x power 2 plus 2x plus 1 over 2x minus 8 multiply x minus 4 over x plus 1. Yes, factorizing. This factorized to be x plus 1 times x plus 1 over 2 open bracket x minus 4 times x minus 4 over x plus 1. Remember that we find the domain before cancelling any common factor. My second step to find the domain. Looking down to the denominators, here x equal 4 and there x equal negative 1. So the domain equal r minus 4 and negative 1. Now I can easily cancel the common factors. X minus 4 will cancel x minus 4. X plus 1 cancel x plus 1. So the remaining parts will be x plus 1 over 2. So easy to multiply. Number 4. N of x equal x power 3 minus 1 over x power 2 minus 2x plus 1 multiplied by 2x minus 2 over x power 2 plus x plus 1. Let's factorize. This will be x minus 1. This is the difference between two cubes. X minus 1 times x power 2 plus x plus 1 over, this can be x minus 1 times x minus 1. Other part, 2 out, x minus 1 over. This cannot be factorized. There is no number, their product 1 and their sum is 1. And we can use the calculator to check the factorizing and has no real roots. So the domain will be r minus 1. And now we can cancel the common factors, x power 2 plus x plus 1 up and down, x minus 1 with x minus 1, x minus 1 with x minus 1. So the final answer, n of x equals 2. Okay, this is a multiplication exercises. Before we study the other exercise about division, let's study the multiplicative inverse of the algebraic fraction. How to find the multiplicative inverse. In the previous lesson, we know that the additive inverse, we just change the sign of the fractions together, or the numerator alone, or the denominator alone. What about the multiplicative inverse? We studied before how to find the multiplicative inverse. Yes, by flipping the fraction or write the reciprocal. So 3 over 4, the multiplicative inverse of it is 4 over 3. Excellent. 5 over 12, the multiplicative inverse is 12 over 5. So we just flip the number or the fraction. Okay, let's read the definition of the multiplicative inverse. If n is an algebraic fraction where n of x equal b of x over k of x, then n has a multiplicative inverse called n minus 1. So n has a multiplicative inverse called n minus 1. And this n minus 1 equal flip. Yes, k of x over b of x. So to find the multiplicative inverse, we just flip the fraction. What about the domain? The domain of n is r minus set of zeros of k. But the domain of n minus 1 is very important. Listen carefully. The domain of n minus 1 is r minus set of zeros of each of the numerator and the denominator of any of the two fractions. So, when we find the domain of the multiplicative inverse, this time we look to each of the numerator and the denominator, the two together. Okay? The domain of n minus 1 is r minus the set of zeros of each of the numerator and the denominator of any of the two fractions. For example, if n of x equal x plus 1 over x minus 5. So, n minus 1x, yes, I will flip it. X minus 5 over x plus 1. We flip the fractions. What about the domain of n and domain of n minus 1? Yes, domain of n, r minus set of zeros of the denominator, r minus 5. But the domain of n minus 1 is r minus, yes, we look to both of the numerator and the denominator are minus 5 and negative 1. Let's go back to your booklet, page 51, exercise 5. N of x equals 3x minus 15 over x plus 3. Divide 5x minus 25 over 4x plus 12. Do you remember when you started the multiplication of fraction starting from primary 5, primary 6, prep 1? We changed the operations into multiplication. How come? We write the first fraction as it is. We write the first fraction as it is. We change the sign of division into multiplication. And then write the multiplicative inverse of the second. So we flip the second. Keep, change, flip. Keep, change, flip. Okay? So if I have division problem, I will change it into multiplication by keep the first, change the sign, and flip the second. So n of x here equals 3x minus 15 over x plus 3 time, we change the sign, then we flip the second fraction, 4x plus 12 over 5x minus 25. Okay, yes, we factorize, we take 3 out, x minus 5 over x plus 3 time 4x plus 3 over 5x minus 5. Yes, pay attention. When we find the domain now, we find the domain. We look to the first fraction and find the domain by looking to the denominator only. But the second one, I will look up and down because here is multiplicative inverse. The domain of the multiplicative inverse are minus set of zeros of each of the numerator and the denominator. This is for the division only, because we change it into multiplication by write the reciprocal or the multiplicative inverse of the second fraction. When we find the domain, we look up and down, both values for x, up and down. So the domain here will be r minus negative 3. And here we look up and down, here already negative 3 and down 5. Then we cancel the common factor, x minus 5 with x minus 5, x plus 3 with x plus 3. So the remaining part 3 times 4 over 5 equal 12 over 5. It's very important when we find the domain in division. After change it into multiplication, the first part looking down as we use, then the second fraction look up and down. Okay, remark the domain equal r minus set of zeros of the denominator of the first fraction and numerator and the denominator of the second fraction. Very important remark. Okay, exercise 6. N of x equal x minus 1 over x power 2 minus 1. Divide x power 2 minus 5x over x power 2 minus 4x minus 5. First step, we have to change the division into multiplication. Keep the first, change the sign, and write the multiplicative inverse or flip the second. I will write x power 2 minus 4x minus 5 up and x power 2 minus 5x down. Then we will factorize as we usually do. So x minus 1 over x minus 1 plus, time x plus 1 time x minus 5 times x plus 1 over x times x minus 5. The domain, yes, pay attention. The domain r minus the set of zeros of the denominator here and numerator and the denominator there. So the domain equal r minus 1 and negative 1, 5, negative 1 and 5. And of course 0. We didn't write the numbers twice, so the domain is r minus 1, negative 1, 5 and 0. After that, we cancel the same or the common factors, x plus 1 with x plus 1, x minus 5 with x minus 5, x minus 1 with x minus 1, and the final will be 1 over x. Okay, number 7. Okay, we didn't solve number 6 yet. Yes. Oh, we solved it, by the way. Okay, number 7. N of x equal x power 3 minus 27 over x power 2 minus 9 divide x power 3 plus 3x power 2 plus 9x over 2x. First, we change the division into multiplication by keep, change, flip. After that, we factorize. This is difference between two squares. Factorize to this form, x minus 3, x power 2 plus 3x plus 9 over x minus 3 times x plus 3 times 2x over x open bracket x power 2 plus 3x plus 9. The domain, yes, this is cannot be factorized, yes, has no real root. So the domain will be r minus 3, negative 3, 0, and this hasn't any rules. So this will be the domain, then cancel the common factor, this with that, x with x, x minus 3 with x minus 3. So the final answer will be 2 over x plus 3. Example, booklet page 53. If n of x equal x power 2 minus 2x over x minus 2 times x power 2 plus 2, first find n minus 1x and identify its domain. Second, if n minus 1x equals 3, what is the value of x? First, to find n negative 1 of x, I will flip the fraction x minus 2 times x power 2 plus 2 over x power 2 minus 2x. I flip it. Then we'll factorize the numerator as it is, and we factorize the denominator x times x minus 2. We find the domain. Listen, n minus 1, the domain will be r minus the set of zeros of each of the numerator and the denominator. So the domain will be r minus here 2. This hasn't any real roots, 0 and 2. So the domain is r minus 0 and 2. This is the first part. Second part, if n minus 1x equals 3, find the value of x. So first I have to cancel the common factors. N minus 1x equal x power 2 plus 2 over x. And this will be equal 3. So I will replace n minus 1x and put 3. X power 2 plus 2 over x equals 3. Cross multiplication. x power 2 plus 2, 3 over 1. X power 2 plus 2 equals 3x. I will replace 3x to be here with different sign. So x power 2 minus 3x plus 2 equals 0. Factorize. This can be factorized to be x minus 2 times x minus 1 equals 0. So x minus 2 equals 0 and x equal to is refused because 2 doesn't belong to the domain. 2 doesn't belong to the domain because the domain doesn't have 2, the element 2, or x equal 1. So example, the last example, complete. Number 1, the domain of the algebraic fraction equals the domain of its what inverse. The domain of the algebraic fraction equals the domain of its additive inverse. Number 2, if n of x equals 3 over x minus 4, then n minus 1, 4. n minus 1 x equals x minus 4 over 3, and when I substitute x with 4, 4 minus 4 over 3 equals 0. Number 3, if n of x equals x over x power 2 plus 9, then the domain of n minus 1 is n minus 1 equals x power 2 plus 9 over x. The domain is the set of zeros, r minus the set of zeros of each of the numerator and the denominator. X power 2 plus 9 has no zeros. There is no value for x, make this 0. And for the denominators, x here equals 0, so the domain will be r minus 0. Okay, my dear students, don't forget to use your booklet to solve the homework. Page 54, exercise 1, and page 55. Thank you and goodbye.